Here's problem 5 on the Kinematics Example problem worksheet. A prisoner is in the second story of a prison which has a window with bars that is 7 meters above the ground. He's trying to escape by having his fellow crony who is on the ground toss him a key. As soon as the key is tossed upwards, it experiences a constant acceleration due to gravity. Remember, the acceleration due to gravity, g, is negative 9.8 meters per second squared. How fast must his partner throw the key so that it reaches the prisoner's hand? How long does it take for the key to reach its target? And what if the key is heavier? Would the partner need to throw the key faster, slower, or the same speed as before? Okay, so we've read it once. We're going to go back and we're going to write our g, and then we'll write our variables. And we'll go back and reread and try to pull out all the variables that are given. Prisoner's on the second story of a prison, which is a window that is 7 meters above the ground. Okay, so the key is going to be tossed to the prisoner, and so it has to end up 7 meters above the ground. So D1 is going to be 7 meters. If the key starts at the ground, we can assume that it's at 0 meters. Now you might say, well, the key's not starting at the ground, the key is starting above the ground because it's in the fellow prisoner's hand. Well, they don't give us that information. They don't tell us how tall he is, so we're going to assume that it starts from the ground, 0. It says, as soon as the key is tossed upward, it experiences a constant acceleration due to gravity. So it's given some initial velocity. This problem begins when the key leaves the fellow prisoner's hand. So we're not dealing with the prisoner pushing. This is not a mechanics problem where you're applying forces. This is only a motion problem. The key is flying upward and it's experiencing a pull of gravity downward. So the initial velocity we don't know. The final velocity when it gets to the window should be 0. The acceleration, negative 9.8 meters per second squared, and we don't know what time. The unknown. How fast must the partner throw the key? That's the initial velocity. How long does it take for the key to reach its target? Time. And a conceptual question. If it's heavier, would the partner need to throw the key faster, slower, or the same speed? So we can say something like, if m increases, what happens to V0? Okay, so that's just a conceptual question. So our first problem, V0. Look at our note card. We need to find an equation that has V0 in it. This one does. We know that D1 is 7, D0 is 0. We don't know what V0 is. We don't know what time is. We can't use that one. This one, we don't know what time is again. This one, we don't know what time is. Let's look at this last one. We know what V1 is. We know what A is. We know what D1 is, and we know what D0 is. So we can use that last equation. V1 squared equals V0 squared plus 2 times A, D1 minus D0. Okay, then we're going to substitute. We have 0 meters per second squared, and that equals V0 squared plus 2 times A, which is negative 9.8 meters per second squared, times D1 minus D0, 7 meters minus 0 meters. Okay. Alright, now let's do the algebra. 0 squared is 0. equals v0 squared plus 2 times 9.8 is 19.6 meters per second squared times 7 meters. If I do the math for that, I got 19.8 negative times 7 is 138.6. I'm also going to move this v0 over here, and that gives me negative v0 squared equals 138.6 meters squared per second squared. That's a negative. Okay. I'm going to divide both sides by -1 and then take the square root of both sides. And you get v0 is equal to the square root of 138.6, which is 11.8 rounded. Now, one thing to note, the square root of meters squared per second squared is meters per second, which is the correct unit for velocity. Well, the second part, time. We look back at our card again of formulas or relationships, and we now know what the final velocity is, the initial velocity, the acceleration, so we can solve for time. Now notice when I go through this, some students have trouble picking the right relationship. I always go through and check the first one, and then the second one, then the third one, then the fourth one. But because this one is a linear equation, it's just easier to solve, and so I'm looking for time. I'd rather rearrange this simple problem than have to use maybe a more complex way to solve this one. This one has a squared term in it. Okay, so I'm going to go ahead and plug it in, and I've got 0 meters per second equals 11.8 meters per second plus negative 9.8 meters per second squared multiplied by time. And I'm going to subtract 11.8 from both sides. And then I'm going to divide both sides by negative 9.8. And my solution, time, is equal to 1.2 seconds. I didn't show that on the screen. Okay, we're going to go back and we're going to graph the position versus time graph, velocity versus time graph, and acceleration versus time graph. If we look at this, we started at 0 and we ended at 7, so we're moving in the positive direction, but we are slowing down. We started with a velocity of 11.8 and we ended with a velocity of 0, which would be a horizontal line on this graph. And so we have big slope on the displacement versus time graph, which would be 11.8, and then we have less and less, and we end up with 0 horizontal line. So it is a concave down parabola. The velocity versus time graph, we start at 0 seconds with a positive velocity of 11.8, and we end up at 0. And the rate of change of this is constant because that's the acceleration. The acceleration is negative 9.8. And so those are our three graphs.